The B-47 bomber, which made its bow in 1947, introduced this new age in the skies. But looking backward beyond this date, what did it take to produce this change? It took vast manufacturing capabilities, like the Boeing plant in Wichita, Kansas, the Boeing Plant 1 in Seattle, the Renton, Washington plant, and Seattle's Plant 2. It took the willingness to investigate everywhere, studying captured documents after VE Day, documents describing radical engineering experiments conducted in Nazi Germany. Finally, sweeping back the wings in the search for a design that would stand up under a jet airplane's extremely high speeds. Putting the theory to the test in the wind tunnel, confirming parts of the theory, discovering that the solution to one problem introduced new ones. The wing should be swept back, yes, but how far? Designing and redesigning. Beyond design, probing into the chemical world's mysteries for new materials, developing methods for handling, treating, processing, and fabricating metals capable of standing up under the rugged conditions a jet airplane must experience. Adding all the investigations into one answer, and back to the wind tunnel for confirmation, by duplicating actual flight conditions and putting the model through its paces. Devising the production methods to get the job done effectively and on time. The old established methods wouldn't do with this larger, more complex airplane. Then securing the jet engines, the proper engines for the big job of flying into the unknown. The B-47, which emerged, is the fastest known medium bomber in the world, the first multi-engine aircraft to exceed 600 miles an hour. The B-47 has won the praise of its pilots, with a majority opinion reading, "She flies and handles more like a fighter than a bomber." Once the 47 proved itself, quantity production was ordered. More than 1,300 have rolled off the assembly line at Boeing's Wichita plant. The Stratojet represents striking force and is constantly on call with the Strategic Air Command in simulated missions.
You have second station. Roger. I have it.
Time to go, 180 seconds. This is the payoff. 3 men, a machine, the skills of thousands of people funnel into these few critical seconds over the target.
You have 30 seconds before bomb release.
Seconds. 5, 4, 3, 2, 1.
The B-47 daily demonstrates the mobility, the strength of modern jet airplanes, providing a round-trip ticket to potential targets anywhere in the world.
Our story begins on the flat prairies of Kansas, the geographical center of the United States. Here, near Wichita, is McConnell Air Force Base. McConnell is known as one of the toughest schools in the Air Training Command. The students of this school are experts, veteran airmen with thousands of hours flying time. Pilots and observers are assigned here for a special purpose. They will learn to fly the Stratojet bomber. In some small measure, this is their story.
Gentlemen, on behalf of the 3520th Combat Crew Training Wing, we welcome you to McConnell Air Force Base. Now, you're here for an intensive training period to qualify you as crew members in the B-47 airplane. Now, to acquaint you with some of the history of the Stratojet, we take you back to 1943, to the dark days of World War II. The B-17, the Flying Fortress, was our mainstay. The Superfort, the B-29, was just starting into production. At the request of the Air Force, Boeing Airplane Company engineers in Seattle began studies on the next generation of big bombers. Bombers with something added, the radically new jet engine. These engineering studies, thousands of research hours, exhaustive wind tunnel and power plant tests, led to a six-jet swept-wing airplane. On December 17th, 1947, exactly 44 years from the day the Wright brothers flew at Kitty Hawk, the first experimental airplane, the XB-47, took to the sky. That flight sparked a revolution. Jet air power was here to stay. Here was a bomber, a big bomber, that flew and handled like a fighter. As for speed, more than 600 miles per hour. By early spring of 1948, the Air Force had decided that it wanted these 47s, lots of them, and in a hurry. This decision led to the reopening of the government B-29 plant here in Wichita, virtually idle since VJ Day. There was a challenge of coordination when hundreds of subcontracting companies from all over the United States joined the Boeing team and began to feed a staggering total of more than 78,000 different items into the B-47 production effort. Then came the challenge of manufacturing problems. To meet the performance formula of higher, farther, faster took the skills of many. It called for closer manufacturing tolerances than even the aircraft industry was accustomed to handling. It was a bomber that had to function perfectly at more than 7 miles above the Earth's surface. All its components had to operate perfectly in temperature extremes from 120 degrees above zero to 65 degrees below. 2 years later, in March of 1950, the dream came to life. The standard production models began to roll off the line. Know-how had solved the problems. Effort and teamwork had overcome the obstacles. 4 years later, 1,000 Stratojets had been built. In 4 short, busy years, we had 1,000 of these excellent reasons for national security. As distance and endurance records for jet aircraft were tumbled by the 47, a continuous program of development kept the Stratojet series out in front. From the current model was developed a speedy photo reconnaissance job designated as the RB-47 and classed as the world's fastest long-range photo plane. We have touched briefly on speed. Speed takes horsepower. The jet engines designed and built by General Electric are rated in pounds of thrust. The 6 jets on this airplane deliver a total of 36,000 pounds of thrust. That, in simple translation, means power. When you put your hand to the throttles of the 47, you have the equivalent of 375 automobiles of 200 horsepower each, right at your fingertips. Still, under some conditions of extreme weight, or when using very short runways, additional power is needed. The answer comes in one neat package, bottle thrust, 1,000 pounds worth. 33 of these bottles, installed externally in a droppable rack, provide an additional 33,000 pounds of thrust for those critical takeoff conditions and literally boost the Stratojet into the air. For takeoff, this means that the fully loaded airplane, weighing over 100 tons, and that's a lot of weight, will be airborne and flying in a matter of seconds. To meet the exacting requirements of the Air Force, the flight test program was exhaustive. It is certainly not by chance that this airplane has proven to be the world's fastest and safest operational medium bomber. So, gentlemen, that's the airplane. Now you'll learn that she flies by teamwork. A combat crew of 3. Aircraft commander, pilot, and observer. Now, you pilots may just as well regard the observer as the blue chip passenger. When you're coming in over the target, it's his baby. When your observer calls for a second station, all this vast program, all this effort, is no better than the observer's skill in those few seconds over the target. Now, your instructors here at McConnell are prepared to qualify you as B-47 combat crew teams. Now, it's up to you.
Yes, it was up to us, all right. And they weren't wasting any time. On our team, a pilot named Sam, a young old-timer with thousands of hours aloft. And there was Tom, our observer, with a built-in calculator for a brain. That's desirable equipment for an observer. And there I was, Cliff, aircraft commander. Our instructor, we were convinced, must have been born in a 47. Because of his background as a stratojet pilot, he could appreciate the problems we were about to encounter. Many of our questions were never voiced. We were already zeroed in on the practical answer. At first, it seemed we were involved in an endless mass of systems and procedures. It didn't seem possible that we could fly this baby with only a crew of 3. It wasn't long before we were beginning to sense the need for close teamwork. Lecture followed lecture, and days became weeks. This was no ordinary airplane. The captain, with charts and mock-ups, really put it across. And a lot of details began to add up. Of course, there were some trifles. 27 miles of electrical wiring, over 1,000 electronic tubes, hydraulics, compressors, accumulators, valves, and gauges without end. The observer's trainer was a duplicate of the bombing devices and the radar equipment which is actually located in the nose of the B-47. Radar, the all-seeing eye, penetrates the blackest night or the thickest clouds. The key to the bombing mechanism is in this small handle. On the final bomb run, it is the observer who flies the airplane. When the observer is ready to take over, he calls for second station. Then his skill and judgment imparted to this handle controls the airplane through the K system, which computes distance, time, speed, windage, drift, and all the other variables. The K system can pinpoint its target, although it may be invisible and 7 miles below. Pinpoint means not an entire city or even a building in that city, but a particular corner of that building. When the pilot hears the observer say, "Give me second station," that's it. Of course, we became thoroughly acquainted with the airplane. Hour after hour, flying with our pilot instructor took out the kinks. The time we'd spent in mock-ups and simulator missions made theory and practice dovetail. Everything smoothed down. We'd sort of forgotten there was to be a day of reckoning. All pilots remember their first solo as something special. There's always a thrill of anticipation on any solo flight. I guess it's the challenge, the realization that the chips are down. It's final. You're on your own. Our instructor was there, prepared to sweat it out with his boys. Remember, he says, Lightfoot Control Radio will keep you in contact. Have a nice ride. And he heads for the airstrip to watch our first solo effort. Not long after, McConnell had made us masters of the 47, and our tour of duty at the school came to an end. We moved on to a squadron of the Strategic Air Command, a top duty assignment worldwide. We deployed 47s to and from overseas bases in Europe, Africa, and the Far East. Sometimes singly, sometimes in strength. Our training never stopped. It intensified. We were constantly on the alert. Strategic Air Command is vitally concerned with perfection in tactical missions. To achieve and maintain the fine edge of perfection, we fly simulated bombing missions against our own cities. Cities which bear a marked resemblance to other targets. A bombing mission begins in the briefing room, where all the details of your assignment are set before you. To be specific in our case, we were to meet a tanker airplane and refuel in the air at exactly midnight that night, and we were to be over our target at precisely 6 o'clock the next morning. Every time you go on a mission, in fact, every time you fly, you leave some solid citizens behind. They are the ground crew. The ground crew shoulders lots of responsibility for millions of dollars in equipment. But more to the point is their concern with human lives. Their skill and knowledge ride with us. In a jet, things happen fast. It's pretty important to know that everything's right. These are the boys that see to it. Without the ground crew, believe me, there would be no team.
Control Tower, this is Air Force 1956.
Ready for takeoff, over.
Air Force 1956.
Cleared for takeoff.
Roger, coming up on power. Gear up. Gear coming up.
AC, this is the observer.
Your first heading is 120.
Roger, observer.
Turning to 120.
Observer from the AC. We're getting into some rough working weather.
How does it look on radar?
AC, this is the observer. We have a good picture. No thunderheads in sight.
Observer from AC. We're breaking through on Tom. And Tom, SCS is not on board.
Roger, Cliff.
Cliff, take up a heading of
165.
Turning to 165.
Hour after hour, boring through the thin air of the stratosphere, on into the night, to a pinpoint rendezvous with the refueling airplane.
Tom, our scheduled refueling time is 2400. It's about 6 minutes to go.
Where's that tanker airplane?
hold your present heading. I have the tanker on radar.
You should have him in sight now.
Roger. I have the tanker in sight. Nice going, Tom. We're going in right on the button. Sam, get set for refueling contact.
Roger, Cliff. Refueling checklist complete. Slipway door open.
Get your credit card ready. She's all yours.
Okay, Sam. Watch our fuel distribution. I'm ready to contact.
For security reasons, aerial refueling contact in Strategic Air Command is accomplished in complete radio silence between tanker and bomber.
Contact made.
This delicate maneuver, calling for the utmost piloting skill, has become so routine with our Air Force that every 3½ minutes around the clock, an aerial refueling is being accomplished somewhere in the world.
Got our load. Okay, pressure disconnect.
Refueled and ready to fly through the long night to the target. A sleeping city 7 miles below. At dawn, exactly 6 o'clock, bombs away.
Cliff, we're almost at the initial point.
Roger.
Start your IP turn in 20 seconds to a heading of 045.
Roger, 20 seconds, turning to
045. Steady on 045. We're on autopilot.
Roger. I have the target on radar. Center the PDI and give me second station.
The PDI is centered. You have second station.
Roger. I have it.
Time to go, 180 seconds. This is the payoff. 3 men, a machine, the skills of thousands of people funnel into these few critical seconds over the target.
You have 30 seconds before bomb release.
seconds. Five, 4, 3, 2, 1.
Vapor trails in the sky, a signature of the dedicated men of Strategic Air Command, perfecting the means whereby we here below may go our appointed ways, unmolested. The signature of those who perhaps are shaping destiny with their strange command, "Give me second station."
In this band, guarding the land, thunder rides here in our hands. When the Air Force takes command, our legions are legends, our wings own the blue. With jets winding free and men
August 2nd, 1954, at the direction of the United States Air Force, a testing program was initiated to determine the maximum maneuver performance of the B-47 airplane, both at high and low altitude. This test was the Combat Maneuvers Program. This film covers only the low altitude portion of the test. The test program was initiated to determine the feasibility of performing a maneuver which could employ bomb release from low altitude in non-level flight. Maximum escape margin for a toss bombing airplane is obtained by performing an Immelman turn. This, then, was the objective. Results of the test, if favorable, could effectively double the bombing capabilities of the B-47, thereby making the airplane a double threat weapon, capable of delivering high-yield weapons either in normal attitude or by toss bombing. The program was conducted at Wichita, Kansas by experimental flight tests in conjunction with the aerodynamics and structures units. The test airplane was completely instrumented for the program. Load data were obtained from strain gauge bridge hookups located throughout the airplane's primary structure. Wing moment, shear, and torsion, body bending moment, and horizontal and vertical stabilizer moment, shear, and torsional loads were recorded. Airplane normal acceleration was measured at several wing stations. At the airplane's center of gravity, nose, and tail. Cameras mounted on the test airplane provided pictorial coverage of various airplane components. A camera located in the fin tip, directed forward along the longitudinal axis of the airplane, provided visual reference of airplane attitude. A camera was mounted on the side of the co-pilot's instrument panel canopy, directed at the left-hand wing leading edge and encompassing the inboard and outboard engine nacelles. A camera mounted behind the pilot provided coverage of pilot technique in performing the maneuvers. Notice the large white-faced accelerometer in the center of the instrument panel. This instrument indicated normal acceleration at the airplane's center of gravity. The tests were conducted under rigidly controlled testing conditions. The Automatic Data Reduction Group, in cooperation with Flight Test Operations and Analysis and Aerodynamics Units, conducted theoretical calculations of B-47 maneuver performance in an Immelman turn. T-33 and F-86 fighter-type aircraft were used for pilot training and for chase airplanes. The basic equations used for theoretical analysis of B-47 performance were checked by flight performance of a T-33 airplane. This investigation revealed that the 12,500-pound T-33 was analogous with the 120,000-pound B-47. The T-33 was also used for pilot familiarization. These flights enabled the pilot to practice and attain proficiency in performing barrel rolls and Immelman turns. The F-86 Pacer was used to reconnoiter the maneuver site
prior to each test to acquaint the test pilot with the magnitude of turbulence in the area. The F-86 was also used as a photo airplane. It is of utmost importance that a pilot be thoroughly familiar with basic acrobatic maneuvers prior to performing maximum performance turns in the B-47. Smoke generators on the outboard engines were used to describe maneuver patterns. Prior to accomplishing an Immelman turn maneuver, the roll response of the B-47 was investigated. A series of barrel rolls was accomplished at airspeeds expected immediately prior to rollout from inverted flight attitude in an Immelman. The roll response of the B-47 proved to be excellent in the speed range of 150 to 370 knots. In a barrel roll maneuver, positive load factor is maintained on the airplane at all times, resulting in an altitude and pitch change. Full aileron deflection was used in the barrel rolls. The rolls were initiated from a 20-degree nose-high attitude. The altitude loss experienced in the roll was approximately the same as the altitude gained in pull-up to nose-high attitude. Recovery was accomplished in every case at or above the altitude from which the pull-up was initiated. It is also extremely important that a pilot be thoroughly familiar with the lateral control limitations of the B-47 airplane at high indicated airspeeds prior to attempting the barrel roll maneuver. Pilot reports indicate that the barrel roll is a very comfortable maneuver in the B-47 and relatively easy to perform. Another phase of pilot indoctrination prior to the maneuver was a wind-up turn on the edge of buffeting. This enabled the pilot to fix in his mind the airplane characteristics when entering buffet at 3G load factor and established familiarity with stick forces at high load factors. This phase was very important as large magnitudes of load factor overshoot could not be tolerated in the Immelman. The test airplane was equipped with J-47-11 engines. These engines were retained on the test airplane due to the cost and time required to convert to the higher thrust J-47-25 production engines. The performance of the test airplane was conservative, as approximately 5,000 additional pounds of thrust would be available in a production airplane. To allow for this thrust differential and increased conservatism, ATO was employed on the first maneuver. Pitch effects from in-flight ATO fire were investigated prior to the maneuvers. Negligible pitch trim change was required when ATO was used. The Immelman maneuver is a half loop with a half roll on top. It is the basic maneuver required for toss bombing. The half Cuban 8 is very similar to an Immelman, except that rollout is delayed until after the 180-degree pitch position is obtained. It allows faster airspeed buildup and return to low altitude. The diagram showing the profile and plan view of the maneuver, plotting altitude against horizontal distance and lateral distance against horizontal distance, can best be used to describe the maneuver. Initially, the airplane is trimmed on about a 10-mile course to the initial point at limit speed. Just prior to the IP, a push force is trimmed into the airplane. This reduces the pull force required to conduct the maneuver. Upon passing over the IP, a pull force is used to apply the desired G to the airplane. The airplane continues to pitch in the first half of the loop. At about the 120-degree pitch position, buffeting occurs. At this point, elevator force is reduced and load factor is reduced as the airplane continues over in the loop to approximately the 10 to 15 degree nose down pitch position. At this time, the rollout is initiated. The airplane enters an erect dive of approximately 45 degrees at this position. The dive is continued at full throttle until limit speed is reached, at which point the throttles are reduced and limit speed is held until the airplane has returned to the initial altitude. By referring to the plan view, it can be seen that a heading change occurs. This is a result of the barrel roll maneuver, which is executed at the end of the half loop. Positive load factor is maintained on the airplane throughout the half roll into the erect dive and causes this heading change. It is then necessary in the dive to roll the airplane slightly to return on a reciprocal of the bombing heading. The first Immelman was initiated at 6,300 feet, 456 knots, and minimum gross weight. 16 ATO bottles were fired to increase conservatism. This was the only maneuver in which ATO was employed, and the use of ATO is definitely not required to perform the maneuver in the B-47 airplane. Prior to pull-up, the pilot trimmed in sufficient nose-up trim so that 50 pounds of push force was required to maintain straight and level flight. This is done to minimize stick force required to pull in and hold 3G. The severity of the maneuvers increased as the program progressed. This maneuver was accomplished at 110,000 pounds. The initiating altitude and airspeed were 458 knots and 6,000 feet. The gain in altitude was approximately 9,000 feet. The fifth maneuver was accomplished with a gross weight of 119,000 pounds. The airspeed was 462 knots and the altitude 4,600 feet. This sequence is representative of a typical 3G maneuver profile. The initial part of the same maneuver is shown as it would appear to a ground observer below the flight path. Paired aileron position was maintained during the high load factor portion of the maneuvers to minimize asymmetrical wing loading. Notice how the wing flexes due to load factor. After the 90-degree pitch position is reached, the pitching rate increases rapidly. Rollout was delayed until the nose had pitched through the horizon, approximately 15 degrees. The 11th maneuver best demonstrated the airplane's usefulness to the Strategic Air Command. The maneuver was initiated at 4,000 feet and 460 knots with a gross weight of 130,000 pounds. The smoke generators were employed in 5-second bursts to describe the maneuver flight path. In general, the test showed that a gain in altitude of approximately 8,500 feet is experienced if a 3G load factor schedule is maintained up to the 120-degree pitch position. This sequence illustrates the heading change that occurs in the rollout from inverted flight attitude. Load factor overshoot did not exceed 25/100ths G in any of the maneuvers despite moderately turbulent conditions. Overshoot was reduced as skill was acquired in performing the maneuvers. The method used by the pilot in performing the maneuver was to initially pull in and hold the predetermined load factor schedule up to initial stall buffet. From this point on, the airplane was held on the edge of stall buffeting for the remainder of the maneuver. The maneuver was a half-Cuban-8 type. Rollout was started after the nose had pitched down approximately 15 to 20 degrees. Moderate buffeting was felt at the vertical. The pilot immediately relaxed load factor and stayed on the edge of buffeting for the remainder of the maneuver. Notice in this fin tip shot that the airplane appears to stop in midair. This was due to relaxation of load factor at buffet entry. After recovery to erect dive attitude, the airspeed was allowed to build up to 425 knots with full power, at which time the throttle was chopped to the idle stop and recovery made at the initiating altitude. The 12th maneuver was initiated at 4,000 feet and 450 knots. The gross weight was 120,000 pounds. The maximum G was 2.5. This condition proves that it is not necessary to hold a 3G load factor schedule in performing an Immelman turn in the B-47. This maneuver would be useful in a tactical situation. The 5/10 additional G available would act as a cushion and allow a margin in cases of over-control on the part of the pilot, or for other unforeseen conditions such as turbulent air. Time to get around is somewhat longer. The gain in altitude was 10,000 feet. It is readily apparent that a sensitive accelerometer is mandatory for performing the Immelman turn in the B-47. As mentioned previously, load factor overshoot cannot be tolerated as the airplane is operating at design limit load factor in most of the maneuvers. The 13th maneuver of the series demonstrated that a wide range of initiating altitudes could be tolerated. Pull-up was begun at 9,000 feet at 440 knots. The gross weight was 100,000 pounds. Pilot technique was the same as the previous maneuver, and the return to initiating altitude was achieved as rapidly as possible. Notice the nose-down pitch angle prior to rollout. This allows faster airspeed buildup and more expeditious return to initiating altitude, which would therefore provide maximum separation between the bombing airplane and point of bomb detonation. These tests were highly successful. The B-47 has proved to be a double-threat weapon, capable of high-altitude level flight bombardment, and now a second accomplishment, low-altitude maneuvers required for toss bombing. This represents maximum utilization of the Strategic Air Command's Sunday Punch.